Hi, and welcome to this video tutorial on the shadow impact analysis solution. Shadow impact analysis can be used to calculate the shadow impact of existing and/or proposed buildings on other features such as the park or neighboring buildings. Now first, we'll use this create sun position task to calculate sun azimuth and vertical angle for the times of day that we're interested in. Now the observer is the feature that we want to calculate shadow impact for. And then you can select your time zone, your date, and time. Next, we will create shadow panels for the observer feature. Start with larger panel sizes first to test the workflow, and then select your obstruction features, such as the surrounding buildings, trees. Now, toggle use observer features as obstruction on if your observer feature can cast shadows. For example, the observer is a building. But in this case, it's a park, so we'll leave it off. Now, the result is a panel feature class showing shadow hours on the observer feature. Now, typically, we want to know what the potential shadow impact of a proposed building is. So we will run the analysis again, but now with the proposed development as obstruction as well. Now make sure your output is a different name than the previous feature class. The results is a panel feature class showing shadow hours for the observer feature with the proposed development. And now we can visually compare the two shadow layers and see the difference. But to get a better indication of shadow difference, we can run the compare shadows task. Enter the existing shadows as base features and the proposed shadows as test features. And then we can see that in the top corner there is more than 3 hours extra shadow, and behind the tree, of course, there is no extra shadow because the tree is there in both scenarios. Now finally, we can calculate the area that will get more than a set number of extra shadow hours using the calculate shadow area task. And then we can see that there in the top corner, the red area, that area will receive more than 3 hours or 2 hours of extra shadow. Now we can run the same analysis for streets and also building features. Now here I pre-calculated the existing shadows, the proposed shadows, comparison between the two, and the area that will get more than 2 hours extra shadow. And as you can see, this is basically the whole street front facade of the building. So now we're ready to publish our shadow results. We can publish to Portal for ArcGIS or ArcGIS Online. And in this case, we'll publish to ArcGIS Online. And we'll do the existing shadows on the park area. Now first, we will create a scene layer package, and then we share this package to ArcGIS Online. So the package is created, and then we'll upload the package to our ArcGIS Online account. Enter a summary, and enter tags, and hit run. So let's go to our ArcGIS Online account. There we have a scene layer package. You click on it, and then you can hit publish. And this will turn our scene layer package into a hosted scene layer. And then we can have a look at it in our scene viewer. Here we have a pre-existing scene. We can search for the layer that we just created. And then we add it to the scene. So this is our existing shadows in the park without the proposed development. And then using the slide functionality, we can show the proposed development. We can show the shadows as a result of the proposed development, shadow difference, more than 2 hours of extra shadow because of the proposed development, and the same for the building. And once we've authored our scene, we can save it and share it with others in our organization or the public. And we're done. Thanks for watching.